Hello, okay, so today I would like to discuss about the experiment that we did last week. So all the regions which have been weighed and all the regions were dissolved in 500 ml of distilled water. And then it turns out the pH result is 4.4, which is acidic. We were supposed to make it to 7.4 pH. So
what do we need to use to adjust the pH?
Oh, actually, in this condition where we get the result is acidic, we need to adjust it to make it neutral. So we add sodium hydroxide, which is an alkaline solution. So then we add it drop by drop until it reaches the required pH, which is 7.4.
Right.
Did you understand? Okay. So PBS, or generally buffered solution, is important and it is necessary to prepare them in neutral condition. Why? Because most enzymes will work well in neutral medium and they need to be in buffered condition, which requires approximately pH of 7.4, which I told you before. Because if the condition is too alkaline or too acidic, the reactivity of enzymes will be lowered or the enzyme will just denature if it is in extreme temperature. So to get the accurate amount of PBS, we need to adjust the pH by using an sodium hydroxide or hydrochloric acid. And second, we need to adjust the volume. By adjusting the volume, we did not directly put 1 liter of distilled water. We started by putting 100 ml of distilled water. And then the pH of PBS was measured by using the pH meter. We call it pH meter. It actually works by detecting the ions present in the solution so that you can determine whether the solution is alkaline, acidic or neutral. So next, Anna, can you tell me the precaution of the experiment?
Yes, Bella. If we do an experiment, there must be an error. So we need to take a precaution step. So basically, the precaution step is how to handle the micropipette, because the micropipette, we all know that it is a quite expensive instrument. So the precaution step is when set a pipette volume, we need to take the volume within only the range of the micropipette. Because if we set the volume beyond the range, it will damage the micrometer gear. And then when using the micropipette, we need to first apply a tip. If we forget to do this, it will ruin the precision piston that measure the fluid volume. And then the third is we always keep a micropipette in a vertical position when there is a fluid on the tip. This is do not allow liquid accidentally run back to the piston. And the last is use your thumb to control the speed at which the plunger rises after the taking up or ejecting fluid. Letting it snap back damage the piston. So this is the precaution for the last week experiment. Thank you.
Alright, hi. So we're going to calculate for number 2. The question is that how to calculate to prepare 100 ml of 2 times solution from 1 liter 10 times solution of PBS. So basically, the thing is that we have to prepare.
Excuse me, what is the meaning of X?
The X is the concentration. So you have to prepare 2 times the concentration from the PBS solution. So now we have to prepare 100 ml of 2 times solution from 1 liter of 10 times solution. That means we have to take a small amount from this 1 liter to make it 100 ml 2 times solution.
Oh, I see.
So that we have to use the formula C1 V1 equals to C2 V2.
What's C1? What's V1?
What the C means and V.
The C is for concentration and the V is for the volume.
Okay.
So the C1 we take what we need to prepare. So the C1 we take this 2x, because what I said earlier that 2x is for the concentration, right?
2 times the
2 times the concentration. So 2x calculate with the volume that we want to prepare, 100 ml equals to C2, the 1 liter, 1000 ml,
C2 is still 10 times.
and V2. We have to put V2.
One is 10 times.
I'm sorry. This is supposed to be 10 times.
Yeah.
We put V2 because we don't know yet how much amount of volume that we have to take from this solution to become this solution. So that so we calculated like usual times.
Rinse all the glasswares that you have used and put it on the table back. Okay?
So we got 20 ml for V2. That means we have to take 20 ml from this solution to prepare this solution. That's all.
Okay, hi. My name is Joash. So I'm going to explain for question number 1. So question number 1 says calculate how to prepare 3 molarity of KCl in 100 ml. Okay. So firstly, we have to find out how many grams of KCl we need to add so that we can get 3 molarity. Okay. So firstly, as we know, number of mole equals to mv over 1000. Okay, m is the concentration, v is the volume. So we have volume here, we have the concentration here. So all we have to do is just add in to find the number of mole. Okay, so number of mole is 3 times 100.
How much is the volume?
100 milliliter over 1000.
Why do we need to divide by 1000?
Because we have for concentration, for the volume, we need to have it in liters.
Oh, okay.
So that's why we divide by 1000. Okay. So if this was in liters, we don't have to divide by 1000.
Okay.
Okay. So our final answer for the number of mole will be 0.3 mole. Okay. So that's 0.3 mole of KCl. So now to find number of mole, there's another formula which is number of mole equals to mass over molar mass. Okay. So now we need to find how many grams of KCl we need. So we already have the number of mole. So 0.3 mole equals to mass that we are finding over molar mass. Now the molar mass is given here, 74.56. So as we calculate mass, we will get 22.368. Alright. So that's the answer.
Okay, then now we are going to do calculation for number 3. It stated that calculate how to prepare 100 ml of 1x concentration of solution of PBS from a stock of 500 ml of 10x solution of PBS. So we are using the formula of C1 V1 equals to C2 V2, where this C1 is actually concentration for solution 1, and then C2 is concentration of solution 2, while the V1 is volume of solution 1 and the V2 is volume for solution 2. So we assume that for C1 the concentration is 10x, we assume, and then we wanted to find how much of it, the 10x solution, the volume to prepare 100 ml of 1x solution. So we put that as an unknown as V1, and then C2 we take it from the first one, 1x, and then the volume is given here, so we convert it to liter, becomes 0.1 liter. And then now we do a mathematical calculation. Here will be 0.1 XL over 10x. We cancel here. You'll get V1 equals to 0.01 L, which equivalents to 10 ml. So 10 ml of 10x solution of PBS is needed to prepare for 100 ml of 1x solution, and the remaining 90 ml, we use distilled water.
Okay, so today for the conclusion of last week's experiment, which is manipulating small volumes and laboratory buffers. So for the first experiment, which is the manipulating small volumes, we learned on how to use micropipettes appropriately. We learned that micropipettes are divided into 3 types, which each one of them comprises of different range of volume. Okay. And then we are able to use micropipettes in the correct way, and we are reminded of the precaution that we need to remember when using micropipettes. Okay, next is for the laboratory buffers, which is preparing the phosphate buffer saline solution. Okay. For the second experiment, we learned the conclusion is we are able to make a solution of phosphate buffer saline solution by diluting salt, and then by diluting salt with distilled water, and then we are able to manipulate the pH of the PBS solution by adding sodium hydroxide with different concentration. And then finally, during last week's conclusion, the conclusion for last week's experiment is we are able to make a buffer solution. We managed to use the micropipettes appropriately, and we learned the ethics in the laboratory.